All right, welcome to Atmosphere in Motion. It's Chapter 8 for ESCI 211, Part 1. So let's get started. So the learning objectives for today's online lecture are these. Understand the definition of atmospheric pressure, the effects of height on pressure, the effects of temperature on pressure. Learn what a pressure gradient force is, how we will measure pressure in the atmosphere, errors in measuring pressure in the atmosphere, learn what a surface and upper air pressure charts are, learn what a constant pressure chart is, and learn what ridges and troughs are. So let's start out with atmospheric pressure. So basically you have this column of air highlighted right here, this column of air, and this column of air has some weight to it, and that will create pressure on the bottom. Okay, so the definition of pressure is the amount of weight of the air column divided by the area this air column takes up, and we refer to this area as a unit area, and so it has an area equivalent to 1. All right, so as we go up in height, the pressure changes. So if we go up, so usually standard atmospheric pressure is 1,000 millibars. So if we go up to 100 millibars, that is 12 kilometers high, and the pressure there is 100 millibars because there's less, a smaller column of air above us. And if you go all the way to the top, you're at 1 millibar, and that's equivalent to about 50 kilometers in the atmosphere. And you have very little atmosphere above you, so you have much less weight. So so basically you get there's changes in pressure at different heights in the atmosphere. Okay, so temperature can also affect pressure. So here's an example. I have column A and column B, and they both have the same height of a column of air. So they have the same 500 millibar pressure line and the pressure at the ground. So what we're going to do now is we're going to change the temperature of column A, and let's make it cooler than column B. So the question will be, what will happen to the 500 millibar pressure line? This is what happens. So the cold air column is denser than a warmer air column. So the air molecules take up less space now. Okay, so basically we call this a shorter cold air column can cause the same pressure as the taller air column at the ground, because you still have the same number of air molecules in A as in B, so you have the same weight for each air column. So, but you don't have to go as high in the cold air column to get to 500 millibars as you would in a warm air column. So the way they refer to this is the warm air aloft is associated with high pressure, okay, and a cold air aloft is associated with low pressure. All right, so okay, let's talk about the pressure gradient force. Air moves always from high pressure here to low pressure. So the air will experience a force from the high pressure towards the low pressure. And this is what we call the pressure gradient force, or PGF. Okay, here's how we measure pressure. We measure pressure in terms of bars. Okay, now a bar is a really big unit, so we like to use a smaller unit. So what we do is 1 bar is equivalent to 1,000 millibars, or MBs, and that's what we measure things in. Now another unit is a unit of Pascal, And 1,000 pascals is equivalent to 1 kilopascal, which is equivalent to 10 millibars. And what we're going to take as standard atmospheric pressure is going to be 1,013.25 millibars. And we'll round this down to 1,000 because 1,000 is a much easier number to deal with. Now you can also measure pressure in inches of mercury or centimeters of mercury. And so standard atmospheric pressure in inches of mercury or centimeters of mercury are these values. And when we talk about instruments, which I'm going to talk about here in a little bit, these inches of mercury and centimeters of mercury deal with what's called a mercury barometer. And then another type of instrument to measure pressure is an aneroid barometer. And it uses basically an aneroid barometer is a small flexible metal box called an aneroid cell. And when atmospheric pressure changes, this box will expand and contract. So if you get high pressure, it will contract, and under low pressure, it will expand. And we can watch this and refer to it as changes in pressure. Examples of these aneroid barometers are altimeters and what are called bar graphs. So what is a mercury barometer? Okay, so this is a mercury barometer, and I believe I'll show you one in class also. But basically, you have some mercury in a pan, and there's a tube here, and as the air pressure outside pushes down on here, this tube, the mercury goes farther up the tube. And so what we do is we measure the distance the mercury goes up the tube, and this would be the inches of mercury above the pan, or in this case, centimeters of mercury above the pan. And that gives us our standard pressure. Now this is what's called the aneroid barometer right here. And so as the can expands and contracts, it pushes this needle back and forth, and we can use this to determine the pressure. And you might have one of these in your house, or could have one trying to figure out if the day is going to be rainy or it's going to have changing weather, fair weather, or dry weather, based on what type of atmospheric pressure you have. Some new smartphones also have built-in barometers. You should check to see if yours does. You might be able to download an app, and it will tell you what the atmospheric pressure is while you're using your app. All right, there are two major types of instrument error that we have to pay attention to when we deal with pressure measurements. One is called station pressure. Every station that records a pressure reading has certain things that will affect its reading. One of these effects is the effect of gravity, or Earth's gravity, or Earth's ability to attract the atmosphere to its surface, and that changes based on where you are on the planet. Each instrument can have a different amount of error, and what the temperature is can also affect the pressure reading. So we have to take those into effect. And the other one is what's called sea level pressure. All these pressures might be at different altitudes in the atmosphere, say in the mountains, and you might be in Denver, Colorado, which is a mile higher than you are at sea level. And so you're a mile higher in the air, so you have one mile less of atmosphere above you, you're going to read a lower pressure. Well, we want to make sure all our pressure readings are correct across the surface of the Earth, and we do this by using what's called a sea level pressure reading. And the way we do that is this. So here are pressure readings at different altitudes or different heights on the surface of the planet, and they've got different readings, and they're at different altitudes. Well, this one has the least amount of atmosphere above it, and here at sea level it has more atmosphere, and of course it's got a higher reading. So we want to deal with this difference in atmosphere. So what we do is we know how high we're above sea level, and we add that to the reading for each location. And that gives us what's called a sea level pressure chart, where I can just look at this chart and I can figure out how the pressure goes across the United States or across Europe based on what altitude these barometers are set at. And you can use these to get a better idea of what kind of pressure systems are going to be coming through your area. All right, so the way we chart these pressure lines is something called an isobar chart. You remember our we made lines of constant temperature graphs, our isotherm plots. Well, they also have isobar plots, lines of constant pressure that go across the weather map. And so basically they connect the dots of all the stations that have the same pressure. Okay, and a rule of thumb is wind blows usually parallel to these isobar lines. It will blow in this direction or this direction here in the isobar lines, especially if you're in upper level pressure chart more than in a lower level pressure chart. Okay, so there's two types of pressure charts, what's called the pressure at the surface and the pressure in the upper level atmosphere. And there's two ways we keep track of those. One is a constant height chart. So what this is it measures the air pressure at the same level of height across the atmosphere, and you get different readings of pressure. And another one is a constant pressure chart, and basically that's the opposite. It records the height level at a constant pressure. Right? Instead of looking at the pressure at the same height level, this looks at what height that pressure level is at. Okay, so this is a constant pressure chart. So on this line right here, it is a 500 millibar surface, and you'll notice in the cold air that this pressure line is lower in the atmosphere, but in the warm air, it's higher in the atmosphere. So this is what is referred to as a constant pressure chart. The pressure along this surface is the same. It's just it's recording the height that each of these pressure points are at. Okay, so with the surface and upper air charts, you get what are referred to as ridges and troughs. So a ridge looks like this. You get these isobar lines lining up with a peak here, and this is called a ridge, and it's usually associated with a high pressure system. And then you can also have a trough axis, and you get these valleys in here, or these troughs in the constant pressure charts. And those are usually associated with low pressure systems or depressions, or the weather system is called a mid-latitude cyclone, and the high pressure system is called a mid-latitude anticyclone. All right, so this finishes all the information for this online lecture today. I just want to remind you that you should have a better understanding of what atmospheric pressure is, how height affects pressure, how temperature can affect pressure, what the pressure gradient force is, how we will measure pressures in the atmosphere, errors associated with measuring pressure that we have to pay attention to. There's two types of pressure charts we like to look at: surface pressure charts and upper air pressure charts. And the most common ones we like to use are constant pressure charts. And then these pressure charts can exhibit trends that are called ridges associated with high pressure systems and troughs associated with low pressure systems. And that's all I have for part one. I'll see you in part two.